All right, so the final topic that I want to discuss is the most advanced topic in this lesson is exponential growth and decay, but it does come directly from the two formulas we talked about when we did our percent increase and decrease, and that was the 1 plus r and the 1 minus r formulas. You'll see that in the next slide. You'll see why they are so closely related. Well, let's just start with the definitions of exponential growth and decay. So please pause your video and try this matching activity. 1, 2, 3, and 4 should each be matched to A, B, and C, A, B, C, and D. All right, give it a try. Write down your answers. All right, hopefully you pause the video and you have your answers. So let's talk about that increasing linear. That would be like A is linear and is always also going up from left to right. So in the same direction you read from left to right, we are going uphill. There we go. And decreasing linear, well, that's this one here. That is D, linear, because it is in a straight line. So when the lines aren't straight anymore, it may well be exponential. Exponential means it's, well, if its growth is going up, right? So this here is exponential growth from left to right, but it's going up faster and faster the further you get. And exponential decay goes down fast at the beginning, but the further you get, the more it tends to level off and is almost horizontal at the end. That's your exponential decay. So if you said A, D, C, B, you got this exactly right. Okay, let's look at the actual formulas for these exponentials. Here are what you should know. You should absolutely memorize both of these formulas here. I use them all the time on the SAT, and I think now you're going to see if you watch the video on percentage increase and decrease with 1 plus r and 1 minus r, you can see why this video comes next because the 1 plus r and the 1 minus r are embedded into a larger formula. So what these formulas mean, the A is like the amount you're trying to find out. Let's say you put money in a bank. The money that you start with is your P, your principal. That's why we use P for that spot, right? That's the starting. And then if you want to know a few years down the road how much money is going to be in that bank after you earn some interest on it, that's the A value. That's typically what you're solving for. Okay. The R is your percent increase or decrease. For instance, if you're getting 2% interest on your savings account, you would use 0.02. And the T is going to be your time. The T is not always in years. Just make sure, like if it's an annual interest, that means if your R value is in years, your T value has to match. It's also in years. If for some reason you get interest every month, and your R value is by the month, then T should also be by the month. So make sure R and T match. All right, so let's try it in the real world. The robot here. So take a moment, read this question about the robot, try answers 1 and 2. Pause the video because I'm going to give it away in 1 second. All right, fair warning, I'm going to give you the answers now. What should the engineer use for X? Well, it is depreciating. That means I'm going to use the 1 minus R, not the 1 plus R, at 15% per year. So that's 0.15 is R. So this is going to be 350,000 times 1 minus 0.15 to the T power, right? And so that's going to be 350,000 times 0.85 to the T power. And that's what the X value is. That's not R. That's after you've done the 1 minus R. So your answer for 1 should be 0.85. I put in an extra 0. Let me fix that. 0.85. And then for number 2, you definitely need your calculator for that part. In thousands of dollars, what is the value? What will it be after 6 years? So you're just going to go here where that T is and make that T value equal to 6 right here. And you can put it into your calculator directly. When you do, you will get 132,000. And if you said that, you're going to have a little trouble on the SAT. The SAT has a box to put your answer in, and you can only get 5 digits into that box, right? But we have 1, 2, 3, 4, 5, 6 digits. You wouldn't be able to type it. So hopefully that would be a clue. You missed something in reading the question if you wanted to say 132,000. What you missed was that phrase at the very beginning in thousands of dollars. So what that means is you would only write the 132. And what that represents is 132 thousands, right? So thousands is like your units. It's not 132 single dollars. It's 132 thousands of dollars. And so that you can definitely type into the test. So do be careful with that. The SAT does like that kind of phrase. And that means you're going to leave off the last 3 zeros if you see it. Okay. All right, let's try just a couple more questions like this. So here's the first one. Pause the video, read it, get your answer. All right, fair warning, I'm about to give it away. This question asks, what is the best interpretation of the number 10? Here's 10. Remember in our formula, this was we use P or principal, or in other words, the starting value. And that means when the hardware store opened. That's D is the correct answer here. So we started at 10 and we grew from there. All right, let's try another question. Okay, here we have an anthropologist, so please pause the video, try this question on your own. All right, fair warning, I'm about to give it away. So if you don't have your answer yet, pause that video. Let's see here, the anthropologist uses this model. By what percent did the population decrease each year? I can see it's a decrease because this is less than 1. So they must have used the 1 minus r formula there. If you use 1 plus r, right, r is always going to be a positive number. So if you use 1 plus r, then your number will be bigger than 1. And if you use 1 minus r, you're going to be decreasing. So then this number, right, is going to have a 0 in front for a decrease. So I can tell that's a decrease. If 1 minus r equals 0.94, I'm going to subtract 1 from both sides. You could be like negative r. If you want to be careful with negatives, is negative 0.06. So that means r equals positive 0.06. And now be careful, they want percent. Not decimal. R actually stands for ratio, but it's not r. They want p. P is 6%. That's the number we're going for. A is our answer here. One more question, then we'll call it a day. All right, question 3. This one's a biggest challenge question because we do have some fractions, or we have more going on in our exponent that you have to think through. So please pause the video, get your own answer. All right, now that you've had a chance to do it, I'm going to give it away. So let's take a look. This increases by 5% every 10 years, and the starting population is 10,000. So I will start, the 10,000 is the easiest part, but you know what? All 4 options have 10,000. If one of them was different, that would have helped me eliminate, but in this case, it didn't get me anywhere. Oh, but the increase by 5% does. Increase by 5%, I know I want a 1.05. So I like this. I do not like B or C. These are both decreases, not increases, because they're less than 1. All right, so I have it down to A and D, but now I have to deal with this every 10 years. If it increases by 5% every 10 years, that's like it's slower than it increased by 5% every year, right? So my exponent is not just the straight up y, it's going to be something smaller than that to slow down the growth. So it takes 10 years to get that first 5% increase. So we want A with the smaller exponent. That 10 in the denominator slows it down. One way you could tell, right, if you were to pick a number for y, just say it's been 5 years, and put that 5 in your calculator, you'll see when you check it with D, you had a growth explosion. What happens in D is it's going to grow by 5% 10 times every year, instead of waiting 10 years to get just that first 5% of growth. So you'll if you were to just pick a number for y and put in your calculator, you'll see here's a huge growth for D, but only a very moderate growth for A. And that's kind of what we're thinking, 5% in 10 years. A is definitely the answer here.